Welcome back to another video from my channel. In our last video, we discussed about representation of data in the form of pie charts, bar graphs, and histograms. Today, we will be discussing about outliers and cleaning data. An outlier is an extreme value that lies outside the overall pattern of the data, which we have discussed as being extreme values if you remember during our discussion of the mean. There are a number of different ways of calculating outliers depending on the nature of the data and the calculations that you are asked to carry out. A common definition of an outlier is any value that is either greater than Q3 plus K multiplied with Q3 minus Q1, where Q3 is the upper quartile and Q1 is the lower quartile. And if you remember, this expression, which is Q3 minus Q1, is basically the interquartile range. Or an outlier is also less than Q1 minus K multiplied with Q3 minus Q1. In the exam, you will be told which method to use to identify outliers in datasets, including the value of K. Sometimes outliers are legitimate values that are acceptable according to the rules, which could be correct. For example, there really could be a giant African land snail of 30 centimeters long. However, there are occasions when an outlier should be removed from the data since it is clearly an error and it would be misleading to keep it in. These data values are known as anomalies, values that are different from what is normal or expected. The process of removing anomalies from a dataset is known as cleaning the data. Anomalies can be the result of experimental or recording error, or could be data values which are not relevant to the investigation. Here is an example where there is a clear anomaly. Ages of people at a birthday party are 12, 17, 21, 33, 34, 37, 42, 62, and 165, where the mean is 47, the standard deviation is 44.02, the mean plus 2 standard deviation is 135.04. The data value recorded as 165 is significantly higher than the mean plus 2 standard deviation, or also known as 2 standard deviations above the mean, so it can be considered an outlier. An age of 165 is impossible, so this value must be an error. You can clean the data by removing this value. You should be careful not to remove any data values just because they do not fit the pattern of the data. You must justify why a value is being removed. You can write 165 is much greater than 135.04, where this notation is used to denote much greater than. Similarly, you can use this notation to denote much less than. So let us do some mathematics regarding this to have a better understanding of what outliers are. For number 1, some data are collected where the lower quartile or Q1 is 46 and Q3, which is the upper quartile, is 68. A value greater than Q3 plus 1.5 multiplied with the Q3 minus Q1, or known as the interquartile range, or less than Q1 minus 1.5 multiplied with Q3 minus Q1 is defined as an outlier. Using this rule, we have to work out whether or not the following are outliers. So first, let us evaluate these two values. For the first one, we have Q3 plus 1.5 multiplied with Q3 minus Q1. Evaluating this gives us 68 plus 1.5 multiplied with 68 minus 46. And this gives us a value of 101. Similarly, for the next one, which is Q1 minus 1.5 multiplied with Q3 minus Q1. This gives us a value of 46 minus 1.5 multiplied with 68 minus 46, which is going to be 13. So an outlier is defined to be something that is much greater than 101 and something that is less than 13. Here at number A, which is 7, we can see that 7 is less than 13. So this must be an outlier. So we can say that for number A, this is an outlier. For the next one, which is 88, we can see that 88 is within the range. For example, 13 is less than 88, which is also less than 101. So because this is within this range, this is not going to be an outlier. And for the last one, 105, you can see that 105 is greater than 101. Therefore, this is going to be an outlier. For number 2, the masses of male and female turtles are given in grams. For males, the lower quartile was 400 grams and the upper quartile was 580 grams. For females, the lower quartile was 260 grams and the upper quartile was 340 grams. An outlier is an observation that falls either 1 into the interquartile range above the upper quartile, which is going to be Q3 plus 1 IQR, and 1 interquartile range below the lower quartile, so it's going to be Q1 minus 1 IQR. For number A, we have to deduce whether or not these values of the male turtles are outliers. So let us first evaluate these two values. For males, we know that the upper quartile is 580 and the lower quartile is 400. So first we can evaluate the interquartile range, which is going to be Q3 minus Q1. If you remember my previous videos, which should be 580 minus 400, that gives us 180. Now we can evaluate the first one, which is going to be Q3 plus IQR. Q3 is 580 and IQR is 180, and this gives us a value of 760 grams. And similarly for the next one, which is Q1 minus 1 IQR, this is going to be 400 minus 180, which is 220 grams. Now we can say that anything that has a value of mass greater than 760 is going to be an outlier, and anything that has a mass of less than 220 grams is going to be an outlier as well. So for number A, 400 is within this range as it is both greater than 220 and less than 760. Similarly, 260 is also the same. 550 also falls within this range, and 640 also falls within this range, meaning that all 4 of these masses are not outliers. For number B, we have to evaluate whether these masses are outliers or not. So we can do a similar calculation for the female masses. As we know, for females, the lower quartile was 260 grams and the upper quartile was 340 grams. So first, let us evaluate the interquartile range, which is going to be Q3 minus Q1, or 340 minus 260, which gives us a value of 80 grams. Now we can evaluate these values. So Q3 plus interquartile range is going to be 340 plus 80, and this is going to give us a value of 420 grams. Similarly, Q1 minus interquartile range is going to be 260 minus 80, which gives us a value of 180. So what it means is that anything that is greater than 420 or anything that is less than 180 is going to be an outlier. Here 170 is clearly less than 180, therefore 170 is going to be an outlier. However, 300 and 340 grams are both less than 420, so these two are not outliers. And finally, 440 grams is greater than 420, therefore this is an outlier. For number C, we have to find the greatest mass or the largest mass a male turtle can have without being an outlier. So from the previous workings, we have found out that the maximum mass a male turtle can have without being considered as an outlier is 760, and the lowest mass is 220. Therefore, the maximum mass is going to be a value of 760 grams. And this is our answers. For number 4, which is the last question, the ages of 9 people at a children's birthday party are recorded, where summation of x, which is the sum of the ages, is 92, and the summation of x squared, which is the summation of all the ages squared, is going to be 1421. So we have to find the mean and the standard deviation. So if you remember, mean is going to be summation of x divided by n, which is 92 divided by 9. As you can see here, n is 9 because there are 9 people. So there are 9 ages here, which gives us a value of roughly 10.2 years. And similarly, standard deviation, if you remember from our previous video, is going to be summation of x squared divided by n minus summation of x divided by n whole square. And this gives us a value of 1428 divided by 9 minus 92 divided by 9 whole squared. And this gives us a value of roughly 7.36 years. For number B, an outlier is an observation which lies plus minus 2 standard deviations from the mean. One of the ages is recorded as 30. State with a reason whether or not this is an outlier. So here we can see that an outlier is going to be a value which lies within mean plus minus 2 standard deviations. So first, let us evaluate that value, which is going to be x plus minus 2 standard deviations, meaning it's going to be 10.2 plus minus 2 multiplied with 7.36. So either this can be a value of 10.2 minus 2 multiplied with 7.36, or it can also be a value of 10.2 plus 2 multiplied with 7.36, which is the standard deviation. So it's going to be a value of either minus 4.52 or 24.92. So anything that is within these two ranges is not an outlier. However, 30 is greater than 24.92. Therefore, this is an outlier. For number C, we have to suggest a reason why this age could be a legitimate data value. And as you can see, 30 is not an impossible age to have, because it could simply be the age of a parent. So this age could be a parent's age or a guardian's age. Therefore, we can say that this is a legitimate value. For number D, given that all 9 people were children, clean the data and recalculate the mean and standard deviation. So what this means is that we have to remove the value of 30 from our data. So the new summation of the age is going to be 92 minus 30, because we're removing 30 here, which gives us a value of 62. Therefore, the new mean is going to be a value of summation of x divided by n, which is 62. And because we have eliminated one of the ages here, so the new number is going to be 8 instead of 9 that we had previously. So this is going to give us a value of 7.75. Similarly, we can find the new summation of x squared, which is the summation of the ages squared, which is going to be 1428 minus 30 squared, because we're removing 30 here. Therefore, its corresponding square is going to be removed as well. So this gives us a value of 528. Therefore, the new standard deviation is going to be root of 528 divided by 8 minus 62 by 8 whole squared. And this is roughly 2.44 years. And these are our answers. So thank you all for watching. Please make sure to leave a like, comment, share, and subscribe if you enjoyed my content. See you guys in the next video. Goodbye.